We'll talk about a problem today that has to do with your electric potential. 2 points, and we're adding another point, so that would be our third point. And we will also see if the work is positive or negative. Let me read the question for you. There are 2-point charges, Q1 and Q2. They're dipoles. So one is positive 2 microcoulombs, and the other is negative 2 microcoulombs. They're positioned at adjacent corners of a square, with each side measuring 3 cm. Point A is located at the square center, while point B is situated at the unoccupied corner closest to Q2. Assuming the electric potential is 0 at a considerable distance from both charges, we've got to know the electric potential at point A due to both of these charges. What is the electric potential at point B? And lastly, as a point charge Q3, which is equal to negative 5 microcoulomb, moves from point A to point B, we've got to determine the work done by that added charge by the electric forces exerted by Q1 and Q2. Additionally, we have to know if the work is positive or negative. How do we approach this? Let's have all our required things listed. Okay, so we have to know our VA, got to know our VB, and lastly, we need to know the work. Also, if it's positive or negative. Positive or negative. What we know is we've got Q1, Q2, and Q3. Now, we know that Q1 is positive 2 microcoulombs, negative 2 microcoulombs for Q2, and Q3 is the one that we just added, that is negative 5 microcoulombs. We also said that their position, basically our Q1, Q2 located 3 cm apart, and we also have our point at the center of our square. So let's draw our square here. Because we need to know the potential of point A, considering our Q1 and Q2. The first thing that we need to do is to identify our formula. This is potential difference, or electric potential, or just potential. Now, to get our electric potential, we already know that your V, or the electric potential, or the voltage, electric potential at A, must be equal to 1 over 4 pi epsilon naught times your Q divided by its corresponding R. Now, since we're talking about letter A, we know that considering our 2 charges, we have 2 kinds of distances here, or 2 entities. This could be distance number 2 for Q2, and this could be distance number 1 for Q1. We can't just plug in values, like for point A, I've got to use 1 distance only. In fact, we've got 2 distances because there are 2 charges that could affect our point A. So given that, I can say 1 over 4 pi epsilon naught is actually just K, but if you don't remember what K is, and you remember what epsilon naught is, you can make use of that equation alone, and that just be fine. Is plugging in the values. We know that they're just the same. Okay, they're just the same, and actually your 2 times negative 2, sorry, 2 plus negative 2, that'll be 0. So the whole thing here is 0, and that 0 will be multiplied to this constant. Everything will just be 0. So your VA is actually just equal to 0. 0 volts. Now for our VB, see what we said here a while ago. What's the electric potential at point B, which is located at the unoccupied corner closest to Q2. So let's put our B here. This is our Q2. The corner is this. Let's make sure that we identify this is point B, not really Q3. This is for point B. Now to get our VB, let me just do this. VB. Okay, to get our VB, right here. To get our VB, that is just basically the same approach, but instead of having the D1 and D2 here, because the A is literally at the center, we can have the distance between Q2 and B and the distance between Q1 and B. Now, same approach, we have here 1/4 pi epsilon naught. It's a pi. Epsilon naught times your Q, because we've got two Q's involved here. That's let's stick to R, QR plus QR. Now for Q1, this is R1, Q2, this is R2. Right, now do we have our R's? We do not have our R, but what we know is we have this, and this is a square. So if this is 3 cm, this might be 3 cm as well. This must be 3 cm. So our 3 cm must be converted to your m, which is 0.03 m. From Q2 to point B, that's 3 cm as well. So this is our radius, or distance 1, that's 0.424 meter. And then we can easily plug everything, plug it in here. Okay, so for the work here, we're looking for the work. Right, and just a recap, what do we know here? We know that and there we have it. That is the equation that we're going to be using to get the work here. Work is equal to your Q times your V. There we go. Next, your Q3 is given as -5 times 10⁻⁶ coulombs. Your voltage is from A to B, we got it a while ago as 175 kilovolts. Since this is from A to B, this is VA, which is 0, minus VB, which is -175. So 0 minus negative, that would be positive. So this is already 175 times 10 to the third, which is basically kilo volts. And the answer is -0.875 joules.